That's it.
So Uwe Haberlandt and Alf Belli, Anders Barducci. So you have 3-4 minutes. Go.
Okay, so the title is Suitability of Circulation Patterns for Statistical Downscaling. So that's the object for change assessment of precipitation. And we want to use a stochastic precipitation model conditioned on the circulation patterns for change assessment. And there are usually different requirements or hypotheses which are necessary to be true in order to do that. And we have 3 hypotheses here. The first one is we need a strong relation between the circulation pattern and precipitation. The second one, we need a good reproduction of the circulation pattern by the general circulation model, and precipitation by the precipitation model. And the third one is the most critical. It assumes stationarity of the relation between precipitation and circulation pattern. And the objective of this study is to analyze and to check the hypotheses. So about the methods, we use first objective fuzzy rule-based CP classification according to Barducci et al. 1995, and we use a stochastic hourly space-time rainfall model in different modes. As an unconditional model, conditioned on the circulation pattern frequency, so this requires a general circulation model, then not depending on the CP frequency, but depending on precipitation intensity, so using a delta change approach using the regional climate model, and finally combining B and C using the circulation patterns and the delta change approach. So the data come from northern Germany, from Lower Saxony. It's about 50,000 square kilometer region, and I just switch to the results. The first column talks about the first hypothesis, the second column about the second, and the third. This figure actually is the main message of the paper. I want to switch just to this figure. Now, this figure shows the change in precipitation as predicted by the regional climate model for summer and winter and for 2 future periods in comparison to the past. And these are the 3 downscaling approaches using the precipitation models. The first one uses just the circulation pattern as condition. And if you compare the two, you see when you do downscaling, statistical downscaling, conditional circulation pattern, you cannot reproduce the change signal coming from the regional climate model. The second one uses only the intensity change of precipitation, not the circulation pattern. And this is much closer to that what is as reference coming from the RCM. And the last one combines the two, combines circulation pattern dependence and the change in intensity, and this is in the end closest to that what was given by the RCM. So coming to the conclusions, hypothesis 1 and 2, I didn't speak about that, but it could be confirmed that the CPs have a strong relation to precipitation, and it could be confirmed that the precipitation model produces reasonable weather precipitation. But the third one, that's a big problem. The third hypothesis had to be rejected because the change in precipitation frequency alone is not sufficient to predict change in precipitation. And this is actually a very critical thing because the classical statistical downscaling requiring only the GCM is not really working anymore. You need in addition the regional climate models, and this is an uncertain thing, and with this uncertain regional climate model you might make large prediction errors for the future. Okay.